Grounding conductors on computer numerical control (CNC) machines and injection molding machines is a critical aspect of ensuring electrical safety and proper equipment operation. The primary recommendation is to connect all ground conductors to the same designated grounding lug on the machine. This centralized grounding approach offers several benefits over alternative methods such as directly attaching to the steel frame. A reliable ground connection is essential for several reasons. Firstly, it provides a low impedance path for fault currents to flow back to the source in the event of an electrical fault. This rapid and unimpeded flow of current is crucial for activating overcurrent protection devices such as circuit breakers or fuses, which quickly de-energize the circuit and prevent electrical shock hazards or equipment damage. Secondly, proper grounding minimizes electrical noise and interference, which can disrupt the operation of sensitive electronic components within the CNC or injection molding machine. Thirdly, a well-established ground connection helps to equalize the potential difference between various conductive parts of the machine, reducing the risk of static discharge and preventing damage to electronic components. Now, let's consider why attaching the ground rod conductor directly to the steel frame of the machine is generally not recommended. While the steel frame may appear to provide a convenient grounding point, it may not offer a consistently low impedance path to ground. The frame's construction may involve multiple bolted or welded sections, which can introduce resistance and impede the flow of fault currents. Furthermore, the steel frame may be subject to corrosion or oxidation over time, which can further degrade the quality of the ground connection. A dedicated grounding lug, on the other hand, is specifically designed and engineered to provide a reliable and low impedance connection to ground. These lugs are typically made of highly conductive materials such as copper or aluminum and are securely fastened to the machine's frame to ensure a stable and permanent connection. They are also often located in a position that minimizes the distance to other grounding points within the machine, further reducing impedance. The National Electrical Code (NEC) provides comprehensive guidelines for grounding and bonding electrical systems, including those used in industrial machinery. It is important to consult the NEC and other applicable standards to ensure that the grounding system for your CNC or injection molding machine complies with all relevant requirements. Proper grounding practices not only protect personnel from electrical hazards but also help to maintain the integrity and reliability of the equipment. Poor grounding can lead to a variety of problems, including erratic machine operation, premature component failure, and increased downtime. To ensure a reliable ground connection, firstly, identify the designated grounding lug on the machine. This lug is typically marked with a ground symbol and is located in an easily accessible location. Secondly, use appropriately sized grounding conductors. The size of the grounding conductor should be determined based on the size of the circuit conductors and the requirements of the NEC. Thirdly, ensure that all grounding connections are clean and tight. Remove any corrosion or oxidation from the grounding surfaces before making the connection. Use a suitable anti-oxidation compound to prevent future corrosion. Fourthly, use appropriate grounding hardware. Use listed and labeled grounding connectors and hardware that are specifically designed for the purpose. Fifthly, torque all grounding connections to the manufacturer's specifications. Over-tightening or under-tightening can compromise the integrity of the connection. Sixthly, inspect the grounding system regularly. Periodically inspect the grounding connections for corrosion, damage, or looseness. Retighten or replace any damaged or corroded components. Seventhly, test the grounding system. Use a ground impedance tester to verify the impedance of the grounding system. The impedance should be within acceptable limits as specified by the NEC and other applicable standards. If the ground impedance is too high, investigate the cause and take corrective action. Eighthly, document the grounding system. Maintain accurate records of the grounding system, including the location of grounding conductors, the size of grounding conductors, and the results of grounding tests. This documentation can be helpful for troubleshooting and maintenance purposes. Ninthly, consult with a qualified electrician. If you are not familiar with grounding practices, consult with a qualified electrician to ensure that the grounding system for your CNC or injection molding machine is properly installed and maintained. Now let's discuss specific NEC articles that relate to grounding. NEC Article 250.4 A5 addresses grounding electrode systems and requires that all grounding electrodes be bonded together to form a grounding electrode system. This ensures that all grounding electrodes are at the same potential, which minimizes the risk of voltage differences and electrical shock hazards. NEC Article 250.24 C requires that the grounded conductor be connected to the grounding electrode conductor at the service equipment. This connection provides a low impedance path for fault currents to flow back to the source. NEC Article 250.96 requires that all metal parts of electrical equipment that are likely to become energized be bonded together to form an effective ground fault current path. This ensures that fault currents will flow back to the source and activate overcurrent protection devices. NEC Article 670 covers the grounding of industrial machinery. This article provides specific requirements for grounding CNC machines and injection molding machines. It is important to consult this article to ensure that the grounding system for your machine complies with all applicable requirements. Proper grounding is essential for the safe and reliable operation of CNC machines and injection molding machines. By following the recommendations outlined above and consulting the NEC and other applicable standards, you can ensure that your machine is properly grounded and that personnel are protected from electrical hazards. In addition to the general grounding principles discussed above, there are some specific considerations that apply to CNC machines and injection molding machines. These machines often have sensitive electronic components that are susceptible to electrical noise and interference. Therefore, it is important to provide a clean and stable ground connection to minimize the risk of electrical noise problems. One way to improve the grounding of CNC machines and injection molding machines is to use a dedicated grounding conductor. This is a separate grounding conductor that is run directly from the machine to the grounding electrode system. This dedicated grounding conductor provides a low impedance path for fault currents to flow back to the source and helps to minimize electrical noise. Another way to improve the grounding of CNC machines and injection molding machines is to use shielded cables. Shielded cables have a conductive shield that surrounds the conductors. This shield helps to block electrical noise and interference. The shield should be connected to the grounding system at both ends of the cable. In addition to these grounding techniques, it is also important to follow good wiring practices. All wiring should be done in accordance with the NEC and other applicable standards. Wires should be properly sized and insulated, and connections should be clean and tight. By following these wiring practices, you can minimize the risk of electrical noise and other electrical problems. Now let's discuss common grounding mistakes. One common mistake is to rely on the steel frame of a machine for grounding. As mentioned earlier, the steel frame may not provide a consistently low impedance path to ground. Therefore, it is important to use a dedicated grounding lug. Another common mistake is to use undersized grounding conductors. The size of the grounding conductor should be determined based on the size of the circuit conductors and the requirements of the NEC. Using undersized grounding conductors can compromise the effectiveness of the grounding system. A third common mistake is to neglect to torque grounding connections properly. Over-tightening or under-tightening can compromise the integrity of the connection. Therefore, it is important to torque all grounding connections to the manufacturer's specifications. By avoiding these common grounding mistakes, you can ensure that your CNC machine or injection molding machine is properly grounded and that personnel are protected from electrical hazards. Grounding system testing involves measuring the impedance of the grounding system to ensure that it is within acceptable limits. The ground impedance should be low enough to allow fault currents to flow back to the source and activate overcurrent protection devices. Ground impedance testing can be performed using a ground impedance tester. This device injects a small current into the grounding system and measures the voltage drop. The impedance is then calculated using Ohm's law. The ground impedance should be measured at various points throughout the grounding system to ensure that the entire system is functioning properly. If the ground impedance is too high, the cause should be investigated and corrective action should be taken. Common causes of high ground impedance include corroded connections, loose connections, and undersized grounding conductors. Grounding system maintenance involves inspecting the grounding system regularly for corrosion, damage, or looseness. Grounding connections should be retightened or replaced as needed. The grounding system should also be tested periodically to ensure that the impedance is within acceptable limits. By performing regular grounding system maintenance, you can ensure that the grounding system is functioning properly and that personnel are protected from electrical hazards. Proper grounding is not just a matter of compliance with electrical codes. It is a fundamental safety requirement that protects personnel from electrical shock hazards and prevents equipment damage. By understanding the principles of grounding and following proper grounding practices, you can create a safer and more reliable working environment. The information provided here is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician to ensure that the grounding system for your CNC machine or injection molding machine complies with all applicable requirements. Always prioritize safety and take the necessary precautions when working with electrical equipment. Before working on any electrical equipment, always de-energize the circuit and verify that the equipment is dead using a voltage tester. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not familiar with electrical work, consult with a qualified electrician. Remember that electricity can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical hazards.